started the recording. Okay. Well, last time, of course, we talked about the array implementation of a... Well, actually, not even the implementation. We thought about a couple of ways one could go about implementing an ArrayQueue. We looked at like 3 options, and the third option was the best. And the third option was the idea where we kind of, if we ever ran out of room, we'll just loop back to the beginning if there's space. So the idea here last time we talked about there being a problem with expand capacity with idea 3 because of 2's the beginning. So if this goes like, you know, I'll use letters this time. I know last time I used numbers, but A, B, C, D, that's the order that the thing should come out. But if we just copy things over, we would have A, B, and then oh, and you're telling me I haven't shared my screen. Oh my goodness. How many times am I gonna do this? Okay, let's try this again. All right, here, I'll refresh there. Okay. This is A, B, C, D. This is the order that we should take things off. And on expand capacity, if we simply just copy the things over, well, we have A, B, and then and then C, and then D. But like we've got this horrible gap because really it's like we've inserted it where we've inserted 4 things, 4 nothings between B and C, which is problematic. So we're going to want to do something where, well, if we're doing the copying over, we want to make sure that the things that looped back will follow the B properly. And this is totally workable, but you know, we'll be a little fancier. And what we'll do is when we're doing the copying, we will just automatically move A to index 0. This is not an actual necessary step, but why not? Yeah, okay, and then we have this fancy math of rear equals rear plus 1 mod the capacity. This is incrementing. This is if the increment gets too big, it loops back to 0. So if it became 8, what's 8 mod 8? 0, so it goes back to here. Okay, will this implementation work? Yeah. Okay, so let's have a look at the actual implementation. So here, we've got a couple of key things we're gonna need. First, obviously we want this to be generic, right? So we'll make it template. And we'll have like a default capacity, because why not? Then the attributes with capacity, front, rear, and count. And then we need an array of type T to actually hold on to the things. And we're gonna need that expand capacity function, that method, because we know that whenever we're in queuing, it's possible that we're out of space, so we might need to just make the array bigger. We'll have the 4 like versions of the constructors, the default, the one where we give it an initial size, a copy constructor, and then our deconstructor. Where the deconstructor is probably only going to be responsible for deallocating the array. We'll have a dequeue, we'll have our enqueue, first size and is empty. I mean, these 4 here at the bottom, these are like our typical standard queue stuff. So what am I going to do? Well, discard. Take all this. Go here. Create a new class. There's add class ArrayQueue. Okay, I'll just replace it with everything here. And then of course our ArrayQueue is done. So, I guess I can save it. Let's look at the header. So yeah, so we've got everything here, looks pretty good. All right. So if we go to actually there's no sense going here. So our default constructor, there, we'll just do this. What's in it? Well, it's pretty straightforward. Just, you know, ArrayQueue, capacity is set to the default capacity, front is 0, rear is 0, count is 0, and then create a new array of type T at the specified capacity, where here actually there is no specified capacity, it was the default capacity. Then the other one is just going to be int size. In fact, I better check. Yeah, int size. And the only difference is I'll just set this there. Problem solved. There. There's our not default constructor. The only difference is we're not using the default size. Okay. Copy constructor. All right, let's have a look. Now there's a lot going on, but let's see. So capacity, just copy the other object's capacity, copy the front, copy the rear, copy the count. Make the new array, and then C is less than 0, or C equals 0. Well, C is less than count. Okay, so there's a lot of fancy stuff going here. So C starts at 0, and we're basically going from 0 to however many things are in there. So we will say front plus C. Okay, so we know front starts at some arbitrary position. So we want to, let's say it starts at location X. So location X plus 0 is still the front. And then we mod with capacity. Why? Well, this is just going to make sure that we'll loop around properly. And this, it's the exact same thing except from the other one. So let me draw an example. And of course we increase C. Because this can seem confusing at first, but it's actually not too bad. So if I have my array, and maybe 1, 2, 3, 4, 5. If I have like A, B, C, and D, right? So in this case, front is 0, 1, 2, 3, 4, and rear will be 0, 1, 2. Okay, count will be 4. Count equals 4. There. I guess I can be fancy. F equals rear equals. Okay. So if I start C, so now I have a loop. So this is like the old one, right? C, there, count. C starts at 0. And is 0 less than count? Of course, in this case, it would be 4. So Q at location front plus C, well, front is 4. 4 plus 0 is equal to 4. Mod 1, 2, 3, 4, 5, 6. Well, 4 mod 6 is just 4. So this is dealing with location 4. Then we increase, pardon me, then we increase C. So 1 is less than 4. 4 plus C, which is 1, is equal to 5. And then we'll do like the 5 mod 6. Well, that's still 5. Cool. Then we increase C. Now, is 2 less than 4? Yeah. Nope, gotta scroll down now, running out of room. Where the heck is my mouse? Where has my mouse gone? Okay. I'll just make this bigger. Is 2 less than 4? Yes, of course. Where the heck? My mouse is gone all funny. Is 2 less than 4? Yes. So 4 plus 2 equals 6. 6 mod 6. Well, that's 0. So now we go. So the order so far has been 4, 5, and then 0. Okay, great. And then we increase count. 3, is it less than 4? Yes. So 4 plus 3 equals 7. 7 mod 6 equals 1. So what comes after 1? Then we add 1 to C. Is 4, whoa. Geez, what is going on with my poor, sad computer today? Is 4 less than 4? No. It's not. So there, we're done. So in other words, it was just a fancy way to make sure we're looping back around, because of course, if we go look up here, it should have been 0, 1, 2, 4, 5, 0, and 1, which was the sequence we got 4501. Yay. Cool. Any questions about that? Because here's the thing. I could implement this a lot of other ways. I could make it so I always start at 0. Maybe what I do is I just start at C. There. Start at C. That could totally work. Maybe I do the copy where, okay, sure, it copies the stuff over, but it starts everything at location 0. And I guess the original front should be 0 and whatnot if I were to do it that way. I'm going to have to do extra bookkeeping. Like, there's nothing saying I have to do it this way. But I just am. We could also use, like, maybe we can use, like, that in-queue option like we did with the linked implementation. Maybe that would work as well. Anyways, but we would still have to index the old one. But maybe even from the old one, can we do, like, dot DQ? Well, I guess we can't do DQ because we want to make sure the things stay in there. So I guess we can't use DQ. Okay. And then the deconstructor is actually reasonably simple. All we have to do is delete the array that holds on to this stuff. Remember, we're not going to delete the contents of the queue because this queue object wasn't responsible for those things. It's not responsible for that memory allocation. All it's responsible for is the array that's going to hold the stuff that was given to the queue. Okay. All right. So in queue, we're going to have to watch out for expand capacity. So we're going to in queue. If size is equal to capacity, we're going to have to expand capacity. We know that. Otherwise, queue at location rear is now the new thing that we're adding, element. Update rear, but we're going to have to do that looping around thing with the mod capacity, and then increase count. There. That's all there is to it. But of course, we need expand capacity, but we've already written expand capacities. Oh, somehow it took me to the course's expand capacity, which, funnily enough, I could probably just copy this on over, and it's going to be more or less correct. But let's just go and copy the one from here, because it's going to have that extra fancy thing about starting at location 0. So let's put in our, actually I'll put the expand capacity above. So what's expand capacity doing? Well, double the capacity, make a new array of type T with the new capacity. For I is 0, less than count. Remember, we only want to go to count, not to capacity now, because we've doubled capacity, where the count is still going to be constrained to what the capacity was. Because expand capacity is only ever called if count is equal to capacity. So I from 0 to count, new queue at location I is equal to the old queue at front. And then increment front to be what that fancy looping thing. And then once we've copied everything over, we need to reset front to 0. Rear is going to be what the count is. Why? Well, because that's how this bookkeeping is going to have to work, because we're always making it that when we copy things over, the front is going to go back to 0. And why is rear count? Well, that's just because count will be the difference between rear and front, assuming rear hasn't looped back around, which in this case it won't have because we expanded capacity, so there's no way it can loop back around. It's not possible yet. So we can just set it to count because rear and count would be the same thing. Then we can delete the old queue and then set queue to be whatever new queue is. And again, I sound like a broken record, but when we say delete, we are not deleting the variable that's the pointer. We're deleting what this pointer points to. So there's our expand capacity. This should be all good. Our DQ, well, if we have that same problem where exception isn't found, I'm not sure what was going on there. We're saying DQ, if it's empty, throw the exception. Otherwise, result is Q at front, increase front, but we have to have that loop thing, and then decrease count, return result. That's it. You're going to see that these functions or methods are going to become very, very, like they're similar, right? They're common. There's not that much of a difference when you think about stacks and queues. Sure, they work in their own way, but they have ways to putting things in and taking things out, and there's a lot of similarity. So first, well, just return queue at front, but leave it there so we don't adjust count or anything. Size and is empty. These are easy peasy. There we go. And as we know, we're going to have that issue with the toString because we don't know what T is. So I just built the ArrayQueue. I implemented it all. Should be working just fine. And like before, if this is working just fine, I should be able to just replace this with ArrayQueue. Actually, I guess I'll have to import it first. Oh, I hear the boop. One sec. Include ArrayQueue. All right, what was the question here? Can you explain the in-queue with expand capacity slower? Sure, but it's the same as every other expand capacity we've done so far. So this is like the 4th time we've seen it, I think. All it is, yes, here we go. All it is if we're out of room, if our capacity is 10 and there's 10 things in our queue, we have to expand capacity. But let's say it's the case where it's not yet. So if that's the case, all we have to do, because rear is always the next available slot, kind of like top is in the stack. So take rear, make it element, whatever the thing we're in queuing is. Then rear +1 mod capacity. This is increment it, but loop around if required. And then increase count. But of course the expand capacity is like the fancy one, right? Because, well, what's going on? Well, this is the same as before. Just double the capacity. We like to double the capacity. Create a new queue called new queue, whatever. It's just an array. So when I say new queue, I don't even really mean new queue. I mean new array that's kind of being used to hold on to the information that is the queue. So create a new array of the new capacity. And then here, what's going on here? Paint. So let's say this is the old array. 1, 2, 3. I've got like A, B, C. Okay, this is front, this is rear. Actually, no, D, because it needs to be full. So now rear is not here. Rear and front, here I'll do like rear and F are the same. So we need to expand capacity. So what do? Well, we take the new queue, which we created, which here, this is 4. So we're going to make the new one. 1, 2, 3, 4, 5, 6, 7, there. And what am I saying? Well, from I, 0 to count. Count in this case is 4. What do I say? Okay, new queue at I, well, it starts at 0. You are going to be whatever the old queue front was. Well, the old queue front is A. So we take that, throw it there. And you see, like, there's no trick to this. There's no like, whoa, hold on, what are you doing? There's magic going on. No, just follow the code. The code, if you're ever confused at what a chunk of code is doing, just execute the algorithm, and then the code tells you what it does. Now, obviously, if you're making some crazy API calls or function calls, sometimes those little function calls can be a hell of a chunk of code in and of themselves, but this is the relatively simple stuff. So we've got A, then we increase front. Okay, front +1, loop back. Well, so 0, 1, 2, 3. So front would have been 3. 3 + 1 is 4. 4 mod 4 is 0, so now front is 0. Okay, I is now 1. Yeah, I is now 1 because we're back here in the for loop. And we increment it. So new queue at 1 is going to be queue at front. Well, front is now 0, so B. Great. And then increase front, mod with capacity, well, 0 to 1. Great. So now front is 1. New queue at 2 is, what's at location 1? Well, that's C. Increment front. I is now 3, so the new one at location 3, or index 3, is now D. And now the for loop's done because we incremented to count. Count was 4. then down here, all we have to do is, well, you know, front was just 2, right? Because that's how we got it here. We were updating the classes, like the attribute front. But of course, that's not the front anymore. We need to actually say, well, no, the front is now actually 0, because that's where we put the thing that should be in the front. So front is equal to 0. And then size, which is 4 in this case, rear will be that 0, 1, 2, 0, 1, 2, 3, 4. So rear is here, which is 4. Because, well, that's just how math works. Rear equals 4, which is equal to size. And that's true because we started front at 0. And then we updated the queue to be, well, not this anymore. In fact, we deleted this, and then queue points to the new array we made new queue. Did that help? And let me know if you have any specific questions about what we went through, because it can be complex. Okay, yeah. So for testing, this is all implemented. Hello world. All I did, look, Control Z, Control Z, Control Z. Okay, yeah. Print queue. Oh, and I'll have to change this to ArrayQueue. Actually, no, this won't even work. We would need a new print queue, I suppose, because the print queue has to take a linked queue the way this is written. So we won't call that. But okay, I'm gonna go here, include ArrayQueue. Okay, so all I have to do for all of this to work, with the exception of print queue, I'm gonna have to get rid of my print queue. Actually, no, let's write a new print queue, but it's gonna take the ArrayQueue. Print queue, ArrayQueue of type TQ. Cur equals QDQ. Wait a minute, no. The ArrayQueue, the linked queue version will work just fine. Look at this. This is actually remarkable. 0 to size, DQ, print it out, and then immediately enqueue it. So this will work. It actually doesn't depend on the type of queue. That's neat. All right. Anyways, linked queue. If I run this, it's going to work just fine, right? In fact, I'm going to do that. And it's still linked queue. I haven't changed it to ArrayQueue yet. All right, it's mad about, wait, array max. Oh, it's mad about the core stuff. Yeah, okay. I don't know what's going on here, but strange. In fact, with course, do I have a stack linked queue, ArrayQueue? I'm just seeing what's going on here, like why throw standard exception. Yeah, why is it not angry here? Whatever. Okay, I just commented out the ArrayQueue header. So we got rid of it from first, and we got rid of it from DQ, just to shut it up so we can make sure everything's working just fine. Okay. Run. Yes. Okay. So this is the same as last time. So here's what I'm going to do. Hello world. All I'm going to do, change this to ArrayQueue. ArrayQueue. And if I did everything correctly, I should not have to change any other line of code here. Oh, I guess except for this, because I'm doing the copy to ArrayQueue. Okay. With the exception of those things, look, whether it's a linked or an array one, we have the method DQ. We have size. We have isEmpty. All of these things, DQ, InQueue, they all exist for the queues if you built the queue correctly. So it doesn't matter if it's a linked one or an array one. So let's see. Let me put my money where my mouth is. Build it. Run it. Look at that. Look at that. It ran just fine. I mean, we can go through line by line to make sure it all checks out, but I'm pretty confident it's all going to check out. So it doesn't matter if I'm using the ArrayQueue or the linked queue. Like, as far as my main is concerned, it doesn't care. All it cares about is that queue is a queue, or is a pointer to a queue. That's all it cares about. The fact that it's an ArrayQueue, yeah, I know it knows because it, it's like the types, right? But at the end of the day, if it can enqueue, if it can dequeue, I can replace this with any other version of a queue as long as they implemented the queue correctly. Isn't that neat? I think it's neat. So, any other questions about the ArrayQueue or queues in general? Because now we're going to move on to inheritance. And inheritance is interesting. We're not going to do too much of it in this class, but I'm going to teach it to you regardless because it is interesting. Looks like I'm not seeing any questions. Okay, well, that's good. I'll just assume everyone understands everything completely. Oh, all right, I hear a boop. What do we got? Hold on as I move my slides around. In templates, is there a way to make a to a string function for specific to make a to make a toString for, okay, so what you can do in C++, I'm pretty sure what you can do is you can check what the type is, and if the type is something it has, you should be able to do it. And if it's not a type of something that can be printed out, then you can like throw an exception or something. I think, but you know what? Don't quote me. I have to relearn C++ every year, and then I never use it. As when April 1st rolls around, or whatever the last day class is, I'm not going to look at C++ again for until like January 1st, 2022, because I don't like C++. There's nothing wrong with it. It's not my go-to language. All right. So if you find a good way to do it, let me know. What language do you normally use? It depends on what I'm doing. So if I'm doing something, okay, most of the time it'll be Python these days. For the type of work I'm doing, it makes the most amount of sense. If I'm writing any code that's going to do any significant amount of like computation where like, okay, speeds are going to matter, maybe I'll switch to something like Java. But that's rare for me. I often don't write those programs anymore because a lot of the AI and machine learning type stuff I do is just, it's implemented like with Python APIs and packages and whatnot and libraries that you can use. So a while ago, I used to be bigger in like your Java and your C, C++. But because Python's just been getting better and better, I just ended up using that most of the time. But there are some downsides of Python, don't get me wrong. If I have to do something that is going to be really, 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 really computationally expensive, and Java, for whatever reason, like I get a feeling that it's not doing the trick, well then maybe I'll try to go to C++. But contrary to what a lot of people will say, so C++, yeah, it can often be faster than Java, much faster. And there's like good reasons for that, okay? But if you go back not that long ago, like people used to be, so one of the reasons Java is slow is because it runs on like a virtual machine, which is basically like a program that's running on your processor, and then that program runs your Java program. Where in C++, you actually generate like the executable, and the zeros and ones that actually just run on your processor. So Java has like this like middleman type thing. So there was a little while ago this project, I can't remember what it's called, Project something or other, that actually was a Java compiler. So it would compile the Java to actually run on your processor. But that project ended up getting abandoned because the Java, what they call like the just-in-time compiler and the virtual machine, were getting so friggin' good that it didn't matter anymore. And when you compile something on Java, like the virtual machine that's running on your computer is like optimized to the max for your specific computer, for your processor. So it's already like by default really optimized. Long story short, C++, yeah, C++ absolutely can very well be faster than Java. Most of the time, the difference won't matter too much though. And also, now that we've talked about computational complexity, if you write an n-squared algorithm in C++, but you figure out how to do like an n log n algorithm in Java, which you could do in C++ too, don't get me wrong. But if you're competing, the n log n algorithm is absolutely 110% the better choice. Like that's better, and Java will appear faster, but that's just because it has a faster algorithm. At the end of the day, like the speed ups you'll get from different languages will depend on what you're doing, because some languages are really good at X, Y, and Z. If you're just making an application, it's not going to matter too much. What else was I going to say? And yeah, the speed ups you'll get to switch to a faster language, well, computational complexity is going to matter a lot more. And the speed ups you can get based on computational complexity, that matters. But in terms of like the speed ups that you'll get from the difference in languages, that's a different thing. So that was perhaps a very long-winded answer to your simple question of what language do I typically use. I used to use C# a lot too. And the reason I like C# is because it's similar to Java, but you use the Visual Studio environment, which I like the Visual Studio environment. It's a really good IDE. And the built-in debugger for C# is phenomenal in Visual Studio. Like half the time it'll be like, here's your mistake, and here's how you fix it. Like it does it. It's magical. I love it. So hopefully you found that interesting. But 99 times out of 100 these days, it's Python. Python. Okay. Inheritance. So this is going to be more of like a theory lecture. So the point of this lecture, what is inheritance? How do I do inheritance? What is overriding? What's casting? How do I use type ID? Yada, yada, yada. So inheritance. This is an idea to derive a new class from an existing one. Why? Well, we can easily reuse existing code from other classes that are relevant to what you're doing. And this is going to save resources. It'll also like help organize code in a logical way. And also when you reuse existing code, it eliminates potential for code redundancy, which can be problematic. So here's an idea. Imagine I had a class that I wrote called vehicle, but then I could specialize, right? I could write another class called car, but a car is a vehicle, right? So I could inherit all the facts about a vehicle, and car will inherit that stuff. And then like I can make a smart car, an SUV or a van, right? And like an SUV is a very special type of a car, which is a special type of a vehicle. And we can inherit things all the way down. Same with like the other way, with bus and school bus, and whatnot. Or shapes, you know, I could have 2D shapes to 3D shapes maybe. And then maybe under 2D shapes, I have circles, rectangles, and triangles. And then under rectangles, well, I have a special rectangle called a square. So a square, it's a shape, it's a 2D shape, and it is a rectangle. But a rectangle is not a square. I mean, it might be, but there's no guarantee. And a 2D shape, it might be a rectangle, but it could be a circle or a triangle. So here's an example. Let's pretend we have a class called bank account. What we have, so like we want to have specialized bank accounts though. We want to have a savings account and a checking account. They're both bank accounts, but the savings and the checking, there's going to be some differences between the two. So these are two new classes that are bank accounts, and we can inherit to save resources. So in this example, bank account is what we would call the base class or the parent class. And the savings account and checking account are the derived or child classes. If we want to write the class savings account and it inherits from bank account class, the savings account class inherits all of the attributes and methods from the parent class. We get all those things for free. We don't even need to write them in, assuming they're written in the parent class, of course. But there are some funny rules that we have to follow to make this work. And there's a good reason for all these rules. We probably won't get into all the heavy-duty theory of why these rules exist at this point. Really what I'm doing is I'm showing you what inheritance is so you're familiar with it, you understand the idea, and you can use it in the future if you feel that you need to. So, if I have something like a base class rectangle, my derived class could be a square. A student, well, I can have an undergrad student or maybe a graduate student. A loan, well, a car loan, student loan, mortgages. You know, there's other examples. Pardon me. You know what? I better keep an eye on the time. Oh, plenty of time still. Derived classes are often called subclasses or child classes, derived classes. The class that the subclasses inherits from is the base class or parent class or the superclass. All words to mean the same thing. How do we do it though? All right, well, let's see some code. We'll use the simple rectangle class for our base class. And then we're going to make a that's the superclass. And square will be the child class. So if you know what, actually I will code this up. So, do add class rectangle. Okay, cool. Now, this is not going to be generic. Like, what does a rectangle have? Well, it's got two attributes, right? Length and width. We've got a constructor. We've got one that takes the values. We've got a copy constructor. And then we have this deconstructor. And you'll notice that it's virtual, which is interesting. We'll talk about this in a second. And then we have a couple of methods here. We've got length, get width, and get area. I mean, we could add more or whatever, but we'll keep it simple. And then we have our toString. Our toString, well, that's easy for this rectangle. You know, we can just print something out. Okay. So let's go to our CPP file, because now we're going to actually start writing in the CPP file again. Rectangle CPP. So we've got a constructor, default 0 and 0. Rectangle takes length and a width. Whatever length and width are, that'll set the attributes. And then the simple functions. Rectangle, the copy constructor, our deconstructor, there's nothing special. And then we got length, width, and area. These are just get length, get width, get area. I suppose maybe I can use setters too for set length and set width or whatnot, but whatever. And then our toString. Okay, so what is this going to do? Well, it just returns a rectangle with just all this information. And let's create one and just poke it a little bit to make sure everything seems to work just fine. Okay. I like my pointers. And let's do like 5 and 10. Right? So, std. What's this mad about? Okay. R dot toString. There. What is it? How did I do it? Okay, that's why. Okay. You know what? I better call the area too. I mean, there's no reason this shouldn't work. Good. Oh my goodness. All right. Build. Run. There. Its area is 50. That makes sense because the length is 5 and the width is 10, and 10 times 5 is 50, and that's how you get the area of a rectangle, right? We all know that. Now, ooh, actually, there was that virtual thing. So if we go back here, if hold on, I'm checking something here.
What? Public double. This is called rectangle area void.
Wait, what did I delete? I may have deleted the wrong function. Oh, I did. Okay, let's get rid of this for a second. Just doing a quick test. Okay, so what this is mad about is it's going to mean more. You know what? Let's save this for the square. Okay. So a rectangle. We defined a very simple rectangle class. It is so simple. Now let's make a square, right? Because a square is a very special type of rectangle. So when we do this, we're going to want to inherit from the rectangle class. In fact, if I go here and do add class, it'll even let me specify the base class as rectangle. Look at that. Now I'm just going to replace it with the copy paste. But now this is the syntax we have. I believe we could put this on one line if we wanted, but we like this format. So class square, colon, and then we have public rectangle after, which is saying, okay, square, but it's inheriting from rectangle. And what are the private attributes? Well, we're not going to set anything here because we get these attributes for free from the parent class. So we don't, pardon me, we don't actually have to write them ourselves, but we do have to write our square, or pardon me, we do have to write our constructors for the square. But I don't need to write get length. I don't need to write get area. I don't need to write get width because I get those for free. So I don't need to include them. But what I am going to do is I'm going to write the function getSide. And getSide is going to be, well, I mean, if we have a square, the length and the width are the same, right? So getSide is really the idea of, well, just return like the length, and that'll represent what all the side lengths are. And we're also going to override the parent's class toString. So toString already exists in the parent class, right? From rectangle. So we got this. It's basically like we copied this function into the square. Just like get area. It's like we copied it into square. Get width, copied. So we copied this, but we don't want to print this out. We don't want to print out rectangle, blah, 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 blah. Although it's technically correct, we're going to want a special version of the toString that's specific for the square. So the default constructor, when I go and write this for square, no, that's not what I wanted. So default constructor. Well, what we're saying here is basically just hijack the rectangles. Because what does the rectangles one do? Well, it sets length and width to 0. Which, sure, that's good enough for the default constructor. And funnily enough, you'll notice that this is mad. It's saying it's inaccessible. Why can't I access length? Length was an attribute we defined for the rectangle. But here's the funny thing. We actually, in the inherited class, don't have direct access to those attributes. But we can access and we can change those attributes with access to the methods, like the publicly accessible methods defined in the parent class, like the constructor. So we're going to do nothing here. And then here's another one. Oh yeah, this hijacks that actually. So that's not the other one. Here's the not default one, square. It's going to take a double S for the side length. And then it's going to hijack the rectangles, except it's just going to hijack the rectangle, the one that takes 2 floats, which if we go and look, that's, or pardon me, 2 doubles, that's this one that takes a length and a width, except, well, they're just going to specify a side length, and then we just give the length and the width the side lengths. I could add more stuff here. This is like if I need to like, okay, call this function, but do anything extra. So whatever this would be. Maybe I do need an extra attribute in square. Like I could add a new attribute called like bool is unit. I don't know. So like the unit square. So it's like 1 by 1. I don't know. So what I can say there is unit. And now this is going to be rather silly. But here, what I can do is in square, what I can do is, so by default is unit. What's going on here? Did I not put the underscore? I did not put the underscore. Is unit equals false, right? Because by default it's 0. But here I can do, okay, if s equals 1, then this is a very contrived example. Do not get me wrong, but I'm just showing you. So this is where we would write special stuff. So what else do we need to add? Well, the copy constructor. Well, the copy constructor is just going to hijack the rectangle's copy constructor because there's nothing special here, except I guess we could add. We could add the is unit. So if object dot, I heard a boop. So what do we see here? Can you only add attributes? No, you can add extra functions too. And we actually did here, right? Like we're adding the get side, which did not exist in the parent class. And if you're wondering, can we only add attributes to what's in the side of the constructor? No, we can do whatever the heck we want there. So if obj dot, what is it, a pointer? No. I guess I can do this dot get length equals 1. There. All right. Else equals false. There. So there's the copy constructor, and then the deconstructor, nothing. So now here we're going to have something slightly different. We're not going to inherit the parent classes. Why? Well, because the specific class is probably going to have special rules for deleting. I mean, in this case, there isn't. But also, because we set in the parent class this to have the special virtual keyword in front of it, it's basically saying if anyone inherits from this, they have to write their own deconstructor. They have to. So, like, they can't just hijack the parents like we did for all the other constructors. Then what else we have? Well, we've got get side. All right, so for get side, all I'll do is just return get width. I could have just as easily done return get length. And yes, I know it's 05, if that's what the boop was about. 205. Great, I'll keep talking. And then so we inherited those for free, the get area and everything, so we don't have to write it. And then otherwise we have the toString. So because get area, get length, get width we got for free, well, now we're just going to override the parent class's toString to just say square with that as a side. And we'll pick up here next time.